This is the HH Factory, and we're going to be spending a lot of time here over the next few months as they finish building our 44-foot floating home about the world. And it's the smallest boat HH has ever built. And last week, we gave you a tour of what she looks like so far.
The most exciting part.
But today we want to focus less on our boat and more on the build process. So we've been running around with our camera, getting to know some of the team and digging into the how and why they build boats the way they do.
It's been a wild ride so far, getting to poke around, and a little bit overwhelming if I'm completely honest, because this is just a massive operation and there's just a lot to take in. And if there is one thing that we have learned, it is that the devil is in the details and the people who manage the details. We were talking about design tolerances and strength and kind of why you build the boats the way that you do.
Strength comes from the fiber and resin matrix, and all our boats are built from epoxy resin. We infuse the epoxy so there's actually no parasitic weight left. The process only puts in the minimum amount of resin, but what's needed to bind all the fibers and hold the fibers in column, much like concrete holds steel reinforcing
and
together.
You use epoxy because it's stronger and you get to use a lot less of it than if you use like vinyl ester or...
True, yeah, we can use less of it. It's an inherently much stronger material than polyester or vinyl ester. We are standing on e-glass here, but this is the wing deck, and we don't need the weight saving or the strength or the stiffness that carbon can offer. But in a lot of areas of the boat where it is an advantage, we can use the carbon, reduce weight because the fiber is so much stronger. And then we use the epoxy to go with it because you've got a very strong fiber. You need a strong resin to hold it all together. You know, another thing we do, all these structures you can see are actually bonded in, and they're bonded in using what we call secondary bonding or lamination process. Everything's taped together rather than a pre-made angle and a glue joint. And when you have pre-made angles and glue joints, which a lot of commercial builders do, you have to have big tolerances, and then you end up with a lot of glue, and it's a very weak joint. Here we fit the bulkhead and the hull together, and then it's actually laminated together. It's just inherently stronger. The cabin soles are structural as well. They're actually all contributing to the global stiffness and strength of the boat. And that's why when you jump on your boat,
it feels solid.
It feels solid. And when you're sailing, it feels solid. It's not conforming to the waves, it's going through the waves.
That's why you use the carbon. But let's also talk about this thing that you say sometimes, which is where the boat is built to fly a hole.
Right, yeah.
The whole flying a hole thing terrifies people, but it's not about because you're gonna fly a hole. So explain to us why do you say that?
So yeah, we say our boats are built to fly a hull, and that's because just like a car is built nowadays with airbags, it's not designed to crash, it's designed to protect you when you crash.
But the whole point of that is its riding moment, right?
Correct, yeah. So all boats, whether they're monohulls or catamarans, have a righting moment. And that's how stiff they are to lean over. And you get to a point where, of course, the boat goes to the point of no return. It will go over. But to get to that point is full righting moment. And that's what we engineer to. And then we add factors of safety on that with all our deck gear and everything. You know, I've built boats all my life, and I've never built a monohull that wasn't designed to be knocked flat by a big gust of wind, and then the keel brings it up again. And it's the same kind of philosophy with our boats. They should be designed to take the full righting moment, and nothing should break. Because there's no point, we get to 10 degrees heel, where you're lifting a hull, full righting moment, and everything starts breaking, and the boat is then dangerous. And that is more dangerous to be disabled at sea because you actually got to a point where you got to full righting moment, rather than the boat kind of coming up, going down. Oh shit, let's put another reef in.
Yeah.
Sorry, I swore. In fact, the 50 owners have never flown a hull. Only our test crew have ever flown a hull in a 50, but we know it can. And it's the same with this boat. I doubt very much if anyone will go hull flying, but it can, and nothing's gonna break. The mast is gonna stand up, the rigging's strong enough, the chain plates are strong enough, the deck gear is strong enough to handle the immense sheet loads and halyard loads and everything else that goes on. And this is the mast bulkhead. This is solid carbon at the top here, taken all, and at the bottom, taken all the mast loads, which are immense when you want a boat to do that. And we know that there's been a lot of recent failures in the commercial catamaran world around structures like this.
Right. That, I think, kind of gets to the heart of what appeals to us so much about our boat, right? Like, we're getting an OC. It's a cruiser's boat, but we get, like, the pedigree, the knowledge, all that trickle-down effect of all that racing history and all that knowledge and, like, that pushing it to the absolute max, because that's what you've always done. You've designed boats to do that. You wanted to push them as hard as you possibly could, and I get like all that knowledge and all that safety built into my boat, basically.
You do. Yeah, you're not going to have pad eyes failing or blocks failing or anything like that. Your winches are set up for optimum line feed angles. The ergonomics of how we've designed everything has been carefully thought about by not only me, but James and all our engineering department, and there's a wealth of experience here.
And speaking of James, he is the naval architect who designed our HH44, and he's practically been building boats since he was in diapers.
Tell everybody a little bit about your whole life, no big deal.
I've always been involved in boat building. I helped my dad build my first Optimus when I was 9 years old, and I've been in and out of boat yards, sweeping floors and learning to laminate and things when I was a teenager, and always hands-on in surf shops, and then went to school, studied yacht design, and eventually ended up here working for HH.
But you've worked on a lot of different projects over the years before you even came to HH. This is not even your first electric boat. You've done a pretty big one before.
Yeah, I mean, working with designers in the UK on a hybrid motor yacht. That was pretty cool. Learned a lot doing that. And even Hudson Yachts, you know, the first gunboat 60s were hybrid. So it's not like these are our first hybrid boats, yeah.
Yeah, so it's not new for you.
Yeah.
This is kind of just bringing everything you've learned over the years all together. Tell us about what goes on in here. What are you doing in here?
So we have lots of different teams. We have structural engineers, you know, the deck gear engineers, interior designers, mechanical engineers, electrical engineers. So I get involved with all of them and make sure that what we're producing really meets our customers' expectations and is really up to the HH standard. We make a drawing for everything. I think one boat is about 200 drawings. For the bigger boats, even more. And we design everything. Nothing is built without a drawing. So that means we have really good quality control and a good ability to actually customize. If the owners want to change some details, we can do it in here before it reaches the shop floor.
Because you have so many different engineers, so many different designers right here, you get to kind of work through everything essentially on paper first before it ever hits the floor, right? So you kind of learn a lot and you get to go through things here before it ever starts to come to life outside.
And before it even gets on paper, we will go through digital mock-ups, you know, again and again. In a 3D model, we can create multiple variations of a design, review it all before, and then maybe we print things out, sketch on them. But yeah, we go through a whole process of review and checking and updating, and it's a long process before a drawing actually reaches the shop floor.
Yeah, and I think sailing's in your blood. You've done it your whole life, so you really kind of come at everything with like the perspective of what's the reality of using this once you're on the boat.
Yeah, and I guess that's probably one of my main roles here is, I mean, a lot of these guys, they're good designers, you know, good interior designer or a good electrical engineer, but they haven't necessarily spent much time on a boat. And so they'll do a really, really great design, and then I might come at it and go, well, as the devil's advocate, I'm the owner, I'm going to kick this or pull that, or I'm going to push that button, what's going to happen? Make sure that everything is robust and functional and aesthetically pleasing. Yeah. So,
a lot to consider, actually.
Yeah. And lightweight, easy to build. There's so many things we have to consider.
Yeah.
Clearly, engineering is the name of the game around here. And when it comes to all things rigging and deck gear, Taka is the man.
The design process we normally went through is we start with the riding moment we need to handle. And we went through a load simulation for all the deck gear, all the lines, the sheet, the tack line, and the halyards. And then we need to design all the deck gears like blocks, winch, organizers when the boat is under seaway. So we need to make it extremely safe. And so far, we don't have any failure on our boat.
You're doing a good job.
Yeah, we are doing it right.
So that we don't end up out at sea and have an undersized winch or a jammer that can't hold the line, and all of a sudden the line starts slipping or it busts because the load was too great, right?
Yeah.
Depending on how the boat's going to get used, right?
Yeah.
Really, it changes all the gear almost,
all the
right?
gear.
Because it's going to be so different for each design.
Because we have different clients, and different clients, they have different expectation on their boat, and we design all the gears, not just the gear, everything based on
How they plan to use the
how
boat.
they plan to use the boat, and we learn new things every day.
Yeah. It doesn't ever get boring, does it?
Oh, never get boring in this job. Yeah, just too busy. Yeah, a lot of things to deal with. Even after a project started, and we probably at a certain stage we would thought we have finished the design and we are good to go.
You're done. Boat's out of
Yeah,
here.
but after 1 year, we are still doing change, and we are still updating technology into the boat.
Still learning, still
Yeah.
making changes.
Yeah. That's like a daily job to us. We do it every day.
Well, that's the same for us out there on the water. Like,
Yeah.
it's not something I don't think you ever master. It's always evolving. You're always
Yeah,
learning.
true.
Yeah. So I
Yeah.
guess same for you,
Yeah,
even on
same
this
for
side.
us.
Yeah. Very cool. I like that.
Yeah.
So as we move further down the line, we get into the nitty-gritty of all of the systems, and there are a load of freaking systems on these boats. And the guy in charge of that, they call him the MEP, Mechanical, Electrical, and Plumbing. His name is Ricardo, and he's supposed to be doing some checks on one of these boats. We're gonna see if we can pin him down for a little bit of an explanation.
So basically this is the heart of the AC side. Very neatly laid out, everything's nicely tessellated and cable tied and quite accessible.
I've been told by more than one person here that you're a bit of a perfectionist, which is really good for us as the customer, but maybe not so great working alongside you in certain cases.
Okay, that's very nice. I think there's another word for it. I think most of the time I said they call me, he's freaking anal. You know, I cut my teeth in an aviation background as an engineer, flight engineer, service engineer. So on an aircraft, everything is definitely labelled. The space constraints are a lot more, and everything just has to fit, and you don't get too many chances of going to service it whilst you're in flight. It's either it's right or you're very wrong. But with that background, I know what you can do, and I always strive to make sure that everybody is trying to improve every boat that we put out. And I must say, over the years, electrics has been probably our biggest bugbear, because of the fact that as the boats have progressed and evolved, the number of pieces of equipment have evolved as well. The technicality of them has exponentially grown, and the complexity of it has gone from a single on-off switch to, Wi-Fi and all sorts of other stuff.
And eco-drive.
And eco-drives, all those things. I mean, these are natural progressions of a good production. And it's always a fine-tuning balance of finding the compromises that suits the customer, suits the boat. And you've got so many facets that have to be factored into it. There's the weight and balance of the boat, and you've got to fit it into the boat. When it's all up, it's actually very neat. I mean, the cover boxes are on, all the labels for every circuit breaker there is, and all the equipment's labelled as what it is and where it's supposed to be. The labels are never on the equipment itself, it's normally next to it, so that if the equipment piece gets changed, it doesn't have to, you don't lose the identity of the piece of equipment. And all this is all repeated in your the technical drawings that come with the boat, especially the electrical side. Literally every wire there is numbered. It's labelled, it's located somewhere on the drawing as to which compartment it's in, under the floor or the cabin or whichever. And then you should be able to find both ends of it, which is always the winner. It's ventilated, air comes out the side, gets extracted out of the compartment and blown overboard.
Now, Ricardo, how tall are you?
I'm 6 foot, I used to be 6'3", but I've shrunk with age. About 6'2" and a bit at the last count in my stocking fit. So I fit in here very comfortably, and I'm not kidding you, you've got wiggle room. A big axiom of mine is that if you're going to put it in a boat, it's going to fail at some stage, probably at the wrong time, the worst possible time, and you need to be able to get to it fast. You need to get to it in situations of stress, and you need to be able to solve the issue when it happens. And that's a format we follow right throughout the boat. There's nothing built into this boat that I can think of that you can't get to, that if you need to change it. I'm not talking about a structural thing or whatever. I'm talking about if there's a piece of equipment, it's accessible. You can pull the wire off it, you can pull the hose off it, you can take the pump out, you can take whatever off, you can get to it. And it's designed that way. We follow that as a hard and fast rule.
In every boat I've ever looked at, I'm just utterly impressed with the layout of all of the electrical, and the tech spaces just always blow me away.
I think our level of boat demands it, our customer demands it, and this is what we've made our niche, our name on, is this little step further that just makes it that exceptionally noticeable. People, and if you've done it right, no one notices at all. It's just beautifully finished, and you think, oh, how'd they get in there? And then all of a sudden you open something up, and bingo, it's presented to you. And that's the artistry, I think, of boat building. Like it's the Ferrari of boat building. You know it's plush, you know it costs a lot, but when you look at it, it's simple.
Yeah.
And, it looks simple, but it functions very well. That's what I believe. That's my Italian heritage. We build Ferraris. But I'm not allowed to use the name. Enzo keeps beating me up about it.
Yes. Yeah. So how many other aspects of your life does this transfer over into? Are you this organized in your personal life, or is it just
very much so. I mean, if you walk into my office, you'll see folders and drawings and things stacked all over the place. And I know where everything is, and I know where to find it if I need it. And I have a wife who's the complete opposite of me, and we work great. She makes a mess, I tidy up. And she cooks really well, and I clean the pots.
Hey, that sounds like our relationship. I make a mess and you clean it up.
It's all about balance. You can't have it all your way, and you don't need to, as long as you got a good partnership on the other side.
That's right. As long as she keeps you on your toes.
Oh yeah.
As the boat's near completion, they do what they call a soft launch. Just put it into the pool. We call it the kiddie pool because this is where you come, you learn how to float, make sure you don't have any leaks, keep the water out of the air in, all your systems get installed and final checks. The mast has just gone on, sails are starting to get attached, like everything is really starting to come together here, including all of the electrical systems, which, because this is HH 4401, yes, it is the furthest along, and they are working on programming the hybrid electric drive.
This is Jessica, and she is the queen of electrical engineering.
I know that it's early days, but tell us a little bit about what you're working on.
So this is the home page. This is the most. This is for all the lighting on the boat.
It's not just here. That would be now on your phone, your tablet, or your outside navigation screen. So if you want to turn on the bathroom light from the helm, you can do that at nighttime and then go down there. That's actually really smart.
We can connect here to Wi-Fi.
So it's essentially all the same stuff.
Yeah, same copy from the B&G display.
Ah, that's really nice.
Yeah, I will show you. For example, all salon lights on, and then also you can choose all salon lights off. Yeah, it's very easy.
Yeah, so you go to bed at night, all the lights are on, you're laying in bed, then you can turn them all off.
Yes, yes, anytime.
Super lazy, I love it, yeah. I love it. Yeah. Now that it's getting close and you're kind of getting towards the end, is it exciting to see it all come together?
Yes, very exciting.
Yeah. Here we are, the final stage where every boat wants to be the big pool. The HH Marina, where every boat eventually makes it for essentially graduation day. Like, 'cause you're all grown up now, you're the boat you've always meant to be, and they do their final checks, tweaking, making sure everything is actually still good to go. And then they lower the gate, you turn right, and you're off and into the big blue. And that's where the real adventure begins. Oh my goodness, that's gonna be us one day soon. Ish. Try not to be too overly excited. And that's it. That's the end of the tour, or as much as I can cram into this one video, because we could nerd out all day, every day for weeks on end around here. There's just that flippin' much. So you're gonna have to help me out and let me know what you're interested in seeing. Help direct me a bit. What do you want to know more about? Drop us a comment down below and we'll do a deeper dive. We'll learn something fun. I got experts out the wazoo around here and I'm itching to take advantage of them. So that's it for us today. But of course, if you've stuck around this long, then you're kind of into this whole factory and boat building thing. Then you should check out our factory tour of Lumar in the UK, where we learn more than you've probably ever wanted to know about toughened windows and what it takes to bust one into 1,000,000 pieces, plus winches and more. All right, see you next time.